exponential growth and decay. The rate of growth is proportional to the population or amount. So that is equivalent to dp over dt proportional to the population. Convert that one to equals k times p. Cross multiply, we get dp over p equals k dt. Then integrate. Integral of dp over p is ln p. And copy constant, integral of dt is t plus c. To get rid of ln, we will use e both sides. So p equals e to the kt plus c. But using the laws of exponents, that one is equivalent to e to the kt times e to the c. But e to the c is c. So this one is c times e to the kt. When the time is 0, the population is equal to initial amount or initial population. So when t is equal to 0, p is equal to po. C e to the k, then time is 0. 0 times k is 0. E to the 0 is 1. 1 times c is c. So c is equivalent to p sub o. So we will replace c here by p sub o. So p equals p sub o e to the kt. So this is now the general equation for exponential growth. So this is growth. When it is decreasing or decaying, the formula is p equals p sub o e to the negative kt. This is for decay. Okay? So, p sub o is the initial amount or initial population. That is when the time is equal to 0. K is the relative growth or the proportionality constant. The time is the small t. The small t is the time. And p here is the population or the amount at any time t. So let's have some examples. The rate at which the population of a bacteria culture grows is proportional to the number of bacteria present. So if the number of bacteria grew from 1,000 to 5,000 in 10 hours, find the number of bacteria after 15 hours. First, write the given. Write the given. At t equal to 0, the population is 1,000. After 10 hours, the population grew to 5,000. Then we are to find the number of bacteria after 15 hours. So what formula are we going to use? Since the population is growing, we will use p equals p sub o e to the kt, positive k. So at t equals to 10 hours, P10 is equal to 5,000. So P is 5,000 at t equals to 10 hours. P sub o is 1,000. E to the k, t is equal to 10 hours. First, we have to get rid of 1,000. So divide both sides by 1,000. So 5,000 divided 1,000 is 5. Then e to the 10k. Then ln both sides. The result is 10k ln 5. Next, divide both sides by 10. So k is equivalent to 1 over 10 ln 5. Next is to find the missing population. So at t equal to 15 hours, P15 is missing. So what is P when the time is 15 hours? P15. PO, 1,000. E to the K is 1 over 10 ln 5 multiplied to 15 hours. So just use your calculator. 1,000 E 1 over 10 ln 5 times 15. Answer is 11,180 bacteria. So how do we use our calculator? So same. Mode, stat, e to the x. Then you input. X is the time. Y now is the population. So when the time is 0, the population is 1,000. When the time is 10 hours, 5,000. So what is missing? Population. So after you input the data, AC, shift 1, then regression, then choose X bar or Y bar. But for this problem, we choose Y bar. Then multiply that to 15. So mode, stat, A to the BX, so 0. Next 10 hours, 1,000, 5,000. AC, shift 1, choose regression, so choose Y bar, then 15. So answer is 11,180 bacteria. So that is for example number 1. Example number 2. The atoms of certain radioactive elements disintegrate, meaning decreasing, such that it is known that the amount of such substances changes at a rate proportional to the amount present. Polonium decays into lead such that after 100 days it has lost 30%. At T equals to 100 days, so P100, it has lost 30% of its initial amount. So what is left is 70%. So we will write 70% of initial amount. Find the half-life of polonium. So we are looking for the time. So when we see half-life, that is half of the original amount. So 50% of the original amount. So what formula are we going to use? We will use P equals P sub O e to the negative KT, since the population or amount is decreasing. So at T equals 100 days, P100 is 0.7 initial amount. So at T equal to 100 days, P is 0.7, P sub O equals P sub O e to the negative K, then time is 100. So we have to get rid of PO first, then E, then negative 100. So, first, divide both sides by P sub O. So, the result is 0.7, then e to the negative 100k. Then, ln both sides. The result is negative 100k ln 0.7. Then, divide both sides by negative 100. So, k here is equivalent to negative 1 over 100 ln 0.7. Then, find the time when the amount is 50%. At t equals to x, half-life is 0.5 PO. So, when the time is missing, P is 0.5 PO equals PO. E to the negative k is equivalent to negative 1 over 100 ln 0.7. Then times t or x because time is missing. So, divide both sides by P sub O. So, 0.5. Then, e to the 1 over 100 ln 0.7 times x. This is now positive because negative times negative is positive. Then, to get rid of e, we will use ln both sides. So, ln 0.5 equals 1 over 100 ln 0.7 x. Then, multiply both sides 1 over 100 ln 0.7. So, we get ln 0.5 over 1 over 100 ln 0.7. So, use your calculator. ln 0.5 over 1 over 100 ln 0.7. Answer is 194. So, it will take 194 days to have a half-life. Then, using our calculator, same process, input the values. At t equal to 0, what is the initial amount? No initial amount, so we will assume any amount. So, here I will assume 100. Then, after 100 days, 70% of the initial amount. So, what is 70% of initial amount? So, 0.7 times 100. 0.7 times 100. 70. So, input 70. Then, AC, shift 1. Mode, start. E to the BX. Input 0. 100. 100. $70. AC, shift 1. Choose regression. What is missing here is the time. So, we choose X bar. Then, multiply it to 50%. So, 0.5 of 100 is 50. So, times 50. So, X bar, then multiply to 50. Answer is 194 days. Okay?